In this video, we are going to learn about heat conversions and heat-related calculations. A typical heat-related question is going to require you to use the equation, which is given as Q is equal to M into CS into delta T. In the lecture slides, it will help you explain Q is heat, M is mass of that system, CS is specific heat capacity, and delta T is recognized as temperature change. It is important to recognize that temperature change, or delta T, is always final temperature minus initial temperature. Even if you get a negative number for delta T, keep that number in the calculation to recognize what is the heat content. Let's look at a typical question, which is, in this case, asking you to find the heat in joules needed to raise the temperature of 32.0 grams of water from 25.0 degrees C to 33.5 degrees C. We need to first recognize what is the given information. The given information in this case for mass is equal to 32.0 grams. It is important to solve a question like this. Heat capacity for water will also be provided to you, which is 4.184 joules per grams into degrees C. This will be provided to you, so you don't need to calculate or memorize this information. T final in this case is equal to 33.5 degrees C. T initial in this case is equal to 25.0 degrees C. Now, when we are calculating delta T, we must remember that T final is T final minus T initial is equal to delta T. So this will give you 33.5 minus 25.0, and both are in degrees C, and this ends up being plus 8.5 degrees C. This is an addition subtraction problem. Recognize that you do have to remember the decimal place rule. This is 1 decimal place, this is 1 decimal place, so the answer is true to 1 decimal place. Okay, what do we have to find? We have to find the heat. The heat is recognized as Q in this equation, so we need to use this equation to solve for the heat. Okay, so Q will be equal to M into specific heat into delta T. So this is equal to 32.0 grams multiplied by 4.184 joules per gram into degrees C into the delta T, which we have already calculated as 8.5 degrees C. This plus does not mean that it's being added. The plus just means it's a positive number, and that will help you look at the value of heat being plus or minus. When you calculate this with the calculator, you will get the answer as plus 1138.048 joules. Okay, now let's look at the number of sig figs that this should have. There are 2 sig figs here. This is an exact number or measurement, but this is 4 sig figs. This is 3 sig figs. This answer is only true to 2 sig figs. So let's recognize where the 2 sig figs are. 1, 2. But we cannot chop off the number here. Why? This is 1138 joules. We cannot make this 11 joules. We cannot reduce the value of this measurement. Whenever something like this happens, you could use scientific notations to help you get to the right number of sig figs. So changing it to scientific notation could help. So if I change this to scientific notation, I will see that this number equals plus 1.138048 into 10 raised to power 3, because I will move the decimal 3 places. Now, when I have the power designating what is the value of the number, I can easily stop the number at 2 sig figs, which will give me the final answer as 1.1 into 10 raised to power 3 joules. I could also leave this number in a regular form, and that would equal 1100 joules. But as I said, using scientific notation will help you get to the right number with the right power, with the right value.